I think it's time for you guys to try one. Why don't you try number 1? I will kind of briefly write a couple of comments. What rule do I need to do this x squared part? For this part, I need the power rule. What rule do I need for this part? For this part, I need the product rule. What part do I need for this part? For this part, I need the chain rule. And what part do I need for this guy? I need the constant rule. So I'm going to do each piece here. The derivative of x squared is just going to be 2x. For my product rule, I need to figure out the first function is going to be this negative 4x, and the second function is going to be y. So the derivative of negative 4x is just negative 4. You keep the second function, which is y, plus the derivative of the second function is dy dx. And you got to keep the first function, which was negative 4x. Is there any questions about that product rule? No questions. All right. To find the derivative of the next piece, I need to use the chain rule. The derivative of the outside function is 2 times something. I've got to keep the inside. Put a y there. I'm going to multiply by the derivative of the inside, which is dy dx. Is there any questions about that chain rule part? No questions. And then the derivative of, put an equal sign, the derivative of 4 is just 0. So step 1 is just differentiating both sides with respect to x, and we did that. Next, I want to move everything involving dy dx to the left. Well, everything's on the left right now, so it's not so interesting. But I want to move everything that does not involve dy dx to the right. So when I do that, I'm going to have dy dx negative 4x plus 2y dy dx is equal to 4y minus 2x. So I add 4y to both sides, I subtract 2x from both sides, and then I end up with this. The next thing I want to do is I want to factor out a dy dx. So I get dy dx. When I factor this out, I can write this as 2y minus 4x. That's the same thing as negative 4x plus 2y. And then this guy becomes 4y minus 2x. And finally, I just divide. So when I divide, I get dy dx is equal to 4y minus 2x divided by 2y minus 4x. And that's going to be our derivative. Does that make sense for everybody? Is there any questions? Hey, Reagan, do you want to make your announcement right now before we start classwork 2?
Yeah, so I'm just gonna share.
All right, let me make sure you can share your screen. Hold on. Okay. I think you're good. Go for it. Share. If you can.
So no, I'm not gonna share my screen, but I'm just gonna tell that there's gonna be a meeting, a college sleep. It's a good club. It's a welcoming event night tonight from 7:30 to 8. It's gonna be the first introductory meeting tonight. It's gonna be only 30 minutes, very short and straightforward. And the club will have this club will have events like transfer webinars, inviting alumni from UCB or other UCs and CSU. So if you're interested, just join. Thank you.
All right. Awesome. Cool. So you can click on the link in the chat box. He posted something in the chat box if you're interested. It's always nice to hear about transferring and what it's like to school your dreams and stuff like that. Why don't you guys try example 2? Let's do this. This question, I hope, well, I guess my thinking was with the first question, I thought you might struggle a little bit. And this second question is actually very similar to the first question. I mean, it's close to identical to the first question. So hopefully you had more success with the second one. I would say this guy is power rule. This guy is product. This guy is chain. And this guy is constant. So it kind of has the same pattern, you know. So when I take the derivative of x to the 4th, that's just 4x cubed. Now I execute the product rule. The derivative of x squared is 2x. You keep the second function, which is y squared. The derivative of the second function, I need to use the chain rule for the second function. So the derivative of y squared is going to be 2y times dy dx. And then I keep the first function, which is x squared. That's the product rule part. The derivative of the last term on the left-hand side is 3 times something squared. You keep the inside, which is the y. You multiply by the derivative of the inside, which is dy dx. And then the derivative of 5 is 0. So we just leave that there. Now we move everything not involving dy dx to the left-hand side. So this part that does have dy dx, that stays here. And then on the left-hand side, we're going to have negative 4x cubed minus 2xy squared. Now I factor out the dy dx. I get dy dx 2x squared y plus 3y squared is equal to minus 4x cubed minus 2xy squared. Like this. And the last thing I do to get my dy dx is that I divide. So we're going to get negative 4x cubed minus 2xy squared divided by 2x squared y plus 3y squared. And that's going to be our answer. Is there any questions about number 2? Can I check in and get a show of hands for people that managed to get this one? If you're able to get this, if you could raise your hand, that'd be great. All right. All right. Okay. 8's not terrible. For Friday, I guess that's not terrible. Let's try. You want to try another one? Let's try number 3. I hope when you guys look at that left-hand side, you can see that we need a quotient rule. And then with the y squared, I'm hoping your program to automatically see as a chain rule. And the constant thing is going to be a constant rule. Okay. So I have this habit now of highlighting the different pieces, so I guess I'll continue. I'll stop at some point, but. So just a reminder, we'll have a quiz on Wednesday, and that quiz covers the quotient rule. So the quotient rule is the derivative of f times g minus the derivative of g times f all over g squared. You got to know that like well. So the derivative of x squared is just 2x. You got to keep the second thing, the g part, which is x plus y minus. Now we need the derivative of x plus y. The derivative of x is just 1. And the derivative of y is just dy dx. And then you got to keep the top thing, which is x squared, all over the bottom squared, which is x plus y quantity squared. Is there any questions about that quotient rule that I just did?
Professor, in this situation, could we like multiply x plus y on the other side?
Yes. Yes.
But would you want us to use the quotient rule?
I mean, I was trying to get you to use the quotient rule.
All right.
But I can force that to happen by doing something like, if I change the question to cosine of x squared over x plus y, you know what I mean, equal to y squared plus 1, then that would force you to use the quotient rule because it's stuck inside of a cosine. So don't worry about it, Jason, but that was my original intention. Yeah. We'll probably get the same answer at the end. Yours might look different because of algebra. Any other questions about the left-hand side there? All right. Let's take the derivative of the right-hand side now. So the derivative of the outside function is 2 times something. You keep the inside, which is y. You got to multiply by the derivative of the inside, which is dy dx. And I guess you could put a plus 0, but there's no need. The derivative of 1 is 0. So I guess the first thing I would say is I really don't like this fraction on this side. So what I'm going to do is I'm going to multiply both sides by x plus y squared. So when I do that, I'm going to get 2x times x plus y minus 1 plus dy dx times x squared equal to 2 times y times dy dx times x plus y squared. Okay. The next thing I want to do is I want to move everything involving dy dx to one side, move everything else to the other. So I think in this case, I see I have a dy dx over here. I have a dy dx over here. This one does not have a dy dx. So let's write it like this. We'll put negative 1 plus dy dx times x squared minus 2y times x plus y squared times dy dx is equal to, and I'm going to move this piece to the right-hand side. So this becomes minus 2x times x plus y. Is there any questions so far as to what's happening here? I'm just trying to get all my dy dx's on the left. Now, when I look at my left-hand side, this guy right here, This guy right here is fine. We have dy dx times something. When I look at this side right here, the dy dx is buried inside some parentheses. So I can't really factor it out yet. Does anyone know how I handle this term right here? Does anyone know what I want to do? To sort of,
Times the x squared to the inside.
exactly. If you don't mind, I'm also going to multiply the negative into the inside. So this is going to become negative x squared minus x squared times dy dx. And then the rest of it is just here. Does that make sense for everybody so far? Okay. So I need to continue this up here. So now you see I have this one extra term that does not have a dy dx. So let me move that to the other side. So I'm going to have negative x squared dy dx minus 2y times x plus y squared dy dx equal to negative 2x times x plus y plus x squared. I just move that over. Now I'm very happy. I mean, it looks psychologically kind of intimidating, but I have something times dy dx minus something times dy dx, and then I have a bunch of other stuff on the right. So I can now factor out my dy dx. I get dy dx times negative x squared minus 2y x plus y squared equal to negative 2x x plus y plus x squared. And the final step is just to divide. So I get dy dx is equal to negative 2x times x plus y plus x squared, all divided by negative x squared minus 2y times x plus y squared. And this is our derivative. Any questions about this, my friends? This one's kind of long, huh? This is more psychologically intimidating than difficult, in my opinion, but the psychology makes a difference, right? Like, students love it when you get a nice round number as an answer, and if it involves fractions or decimals, it's like, whoa. Okay.